So I'm going to introduce Ben. Ben is a PhD student, Ben Hutchins, PhD student at Reading University. His research focuses on the potential applications of decadal predictions for the energy sector. And as I already mentioned, Ben is a fellow in a fellowship scheme, one of our science engagement fellowship schemes at the Royal Met Society, working with us 1 day a week, focusing on energy. I'll hand over to Ben.
Oh. Thank you, Liz. Sorry, just getting here. So hopefully the slides stay up at least for some time. We might get halfway through and they might fail, so see about that. But yeah, like Liz said, I'm a PhD student at the University of Reading, supervised by David, which is here. And yeah, I'm going to be telling you about the state of the UK climate for the energy sector report. So first of all, I'd like to thank the author team, some of which are here. So I've seen Matt and James. Nice to see you both. I think Hannah's probably somewhere in the north. It's quite a long journey down. But yeah, so Matt was the former Science Engagement Fellow for Energy. So he and Hannah basically came up with the idea for this report and sort of brought it through to reality. And then I sort of picked it up in June and have sort of carried it forwards. And then with the help of James, who's not affiliated with RMETS in any way, but who's been very generous with his time in helping us out. We also have the Energy Special Interest Group, which Liz has mentioned already, and all of these sort of public and private sector bodies have been really sort of instrumental in the genesis and the sort of design of the final report. So I'd like to thank them as well. So first of all, why write this report? So I think when Matt and Hannah were having the initial discussions upon sort of why this report might exist, they sort of identified that there was no systematic review of the weather and climate impacts on the UK energy sector within a given year. So National Grid do produce this winter review and consultation, where after each winter, they sort of see how their forecasts for supply and for margin performed relative to expectations. And there's also the State of the UK Climate Report, which Liz has already mentioned. So I guess the idea was to sort of merge these two things and to essentially write a State of the Climate Report, but more specifically for energy. And to give this context, I think what we want to explore is how the weather of 2023 to 2024 in this case relates to our expectations of past and future climates. And hopefully this will help us to prepare for future extremes. So we know from the third climate change risk assessment that we're expecting annual temperatures to increase for the UK. We're expecting less summer rainfall, more winter rainfall, and potentially some sea level rise as well. But we don't really go into much detail in this report of the impacts of climate change on the energy sector. So, little spoiler there. So in terms of the scope of the report, what we can and can't do. So one of the main things that we can do is review the impacts of weather over the past year. And we do this using energy reanalysis data, which I'll get into on my method slides. And this is how we identify challenging events for supply and demand. We can also potentially speculate on the future impacts on the energy sector, given our understanding of climate change. What we can't do is we can't drill into every single event which occurred between 2023 and 2024, particularly the sort of demand net wind events, times when sort of margins were tighter than they were normally, because there's quite a few of those within any given winter. So we've chosen to highlight two case studies here. We also can't necessarily provide any advice to the energy sector on how to respond to this. So the author team, we're all meteorologists, energy meteorologists. We're not engineers or power system operators, so that's not our specialty really. We also can't predict the future. So when we're speculating on impacts with climate change, it really is just that speculation. So how do we do it? So this is kind of the method slide. So one of our main tools is reanalysis, also sort of colloquially referred to as maps without gaps, produced here at ECMWF. So these are spatially and temporally coherent maps of surface variables, so in this case, temperature and wind speeds, where we take a best guess of the current state of the climate using the global observing system, combine that with a reforecast, and then you get these spatially coherent maps for the given period. We've also had a lot of help from Hannah in this when she created these energy reanalysis data sets on one of her mini postdocs. And these essentially use empirical and physical relationships to quantify energy variables based on the meteorological variables which we've got here. So one example of this would be the relationships between electricity demand and temperature, which we can sort of break down into two sort of linear functions via heating degree days and cooling degree days. There's also physical relationships between wind speed and wind power. So this is just a simple power curve for any given wind speed. We expect a certain amount of output from a wind turbine. I think it's important to emphasize, though, that these are modeled energy variables. These are not the actual sort of gigawatts of demand or wind power generation that we're seeing during the periods. So Hannah has done some verification, and they do perform quite well against the actual observed data, but I just thought that would be worth emphasizing. We also used some fault data from DNOs. So we had data from Northern Power Grid and Electricity Northwest, and that was really helpful for giving us more of an understanding of what the impacts of winter storms were in the north of England. We're hopeful that if we do this report next year, we might be able to get more DNO data, because obviously that's not full coverage of the UK, but that's kind of a next year problem. So, so how do we generate electricity in 2023? So this is a figure from the ESO. Most of it is from gas, just over wind. So gas and coal was about 33% of our total capacity within 2023. Renewables made up about 50%, so mostly dominated by the wind, but also from solar and hydro. So the UK was a net importer of electricity in 2023. So interconnectors with our European neighbours are becoming much more important as a part of the energy mix. And it was also the greenest year on record, mostly sort of contributed by the sort of windy conditions that we had. And then in terms of setting the scene for demand, so we saw our highest demand right in the middle of winter, I think during quite a cold spell, at the 5 p.m. peak, when everybody comes back from work and switches on their kettles and stuff. So that's when we saw the highest demand of about 44 gigawatts, and the lowest demand was early in the morning in the summer of around 14 gigawatts. So in terms of, again, not a spoiler, in terms of the state of the UK climate report and the sort of main findings from that and how they might relate to energy. So 2023 was the second warmest year on record since 1884, very narrowly pipped to the post by 2022. But obviously there's the warming trend there, which we're all aware of. It was the 7th wettest year on record since 1836, mostly from a very wet autumn and spring. And we also had lower wind speeds than the 1991 to 2020 average. And there's also a slight sort of stilling trend over the past 50 years, which is potentially interesting. We had a very active start to the storm season with 7 named storms between September and December 2023, which was actually the most active start to the storm season since the naming system was introduced in 2015. And yeah, you can see some of the storms here. So in terms of how we sort of divided up the report, we divided it into 2 sections. So first looking at events where margins were tighter than they were normally, relating to electricity supply and demand. And then the second section, which I'll get onto later, was infrastructure damages due to winter windstorms primarily. So just to set the scene for how temperature relates to demand and wind speed to wind generation, generally in the UK, demand is sort of inversely correlated with temperature. During the summer, when we have the sort of warmest temperatures, we have the lowest electricity demands, and the opposite is true during the winter. So winter is essentially the more challenging period for high demand events. And then, as you might expect, wind speed and wind power are pretty closely related. So the way that we sort of fold these 2 variables together is by looking at demand net winds, which is just the simple differences between the weather-dependent electricity demands and the wind power generation. And in this green line here, you can kind of see the peaks. Those are when there were potential issues for sort of supply security. Now, ESO do a lot of balancing measures, so we didn't really experience any severe issues, but we're just kind of highlighting the times where we had sort of less renewables than we would expect. We also did consider adding solar into this, because a lot of the events that we see occur in the winter when solar generation is fairly low anyway. It didn't make much difference to our results, so we sort of focused on demand net wind for simplicity. We identified 2 events here, so one in September during quite warm conditions, and one in the early winter, so the end of November, early December, during a very sort of cold spell. And I'll go into those in a bit more detail. So if we take the sort of simple differences between, so this is the climatology, which I forgot to explain, between 1990 and 2022. If we take the simple differences between the climatology and the absolute values, we can get the anomalies. And this just helps to highlight more clearly the events that were challenging for the energy sector. So we've got a few sort of popping up in early 2023, and we've also got some in early 2024 as well. But the sort of worst demand net wind event, at least from our sort of modelled data, was at that early winter period in November, December 2023. And then our sort of only summer event was sort of this spell in September, where there was much lower wind generation than normal. Demand was sort of fairly normal for the time of year, which sort of contributed towards that. The winter event was very typical. Again, I'll go into more detail later, with high pressure conditions leading to cold and still conditions. And these sort of pop up in the daily temperature anomalies during 2023. So that's our very warm September event. And then this is our cold winter event. And you can also see these sort of early winter events popping out here, so in January and March. So the first one of these was the September heat wave between the 4th to the 11th of September 2023. So here we had the jet sort of kick to the north, which allowed high pressure to build across the UK. And somewhere in England, 30 degrees was exceeded each day between the 4th and 10th of September 2023. So really hot conditions, and you can see the warm days in the GIF here, and you can see sort of the still sort of southerly winds coming through here. So a rapid attribution study done by the Met Office found that these hot events in autumn are becoming much more likely, and that if you sort of looked at whether they would occur in a pre-industrial climate, it's actually very unlikely to see these sort of events. And like I mentioned, the sort of primary driver of the anomalously high demand net wind at this time was the low wind power generation, about 5 to 10 gigawatts lower than normal. It's also expected that summer events like this are potentially likely to become more challenging in the future. As more care homes and even residential homes install air conditioning, we're going to get more demand effects related to air conditioning. And so say we had low wind power generation combined with much higher demands because of the warm temperatures, that would make an event like this much more challenging. We also have our cold snap event, where we've got a fairly typical neo-negative pattern over the Atlantic, high pressure building over Scandinavia, bringing in sort of cold northeasterly winds over the UK. Again, this is a fairly typical sort of winter event leading to high demands and low wind power generation. And there's a question about, in the future, will events like this become more challenging as wind power makes up more of our energy mix? So in terms of summarising the supply security section, so I guess our main finding was that the UK power system is resilient. This will be a sort of running theme through the report, as we had no serious supply security issues requiring widespread outages or backup generation between January 2023 and April 2024. We identified these two high demand net wind events in September and early winter. The September heat wave event was driven by low wind power generation, and the winter cold snap was driven by, I guess, both demand and winds. And future events we expect are likely to be driven by similar conditions, but with a changing power system, it's hard to say how severe these might be. And obviously there's uncertainty with climate change. We know that winters are likely to become warmer, but there's much more uncertainty relating to the dynamics of winter blocking events and how these might change in the future. Which sort of brings me on to my next section, thinking about winter storms. So why do we care about winter storms? We care about winter storms because they impact the distribution network. In the UK, the distribution network looks something like this, where we've got the main sort of transmission line, which is run by National Grid, which is those sort of large pylons which are fairly resilient to damages. But when the sort of at the more regional level, you have, well, underground cables, which are kind of all right, but then you have the poles, which are vulnerable to falling over in the winter. So yeah, that's kind of the main issue. So here's just an example from Storm Babbitt of a tree falling. This tree did not fall on a line, but you could imagine that the line was there maybe. You can also have flooding impacting substations. So here's a picture from, I think, the southwest during Storm Kieran. Again, transmission infrastructure, fairly resilient. If you would have had a substation here that might not have been raised, then you could have got into issues there. You can also have issues where successive storms hamper recovery efforts. So this was the case with Aisha and Jocelyn in early 2024, where there were these extensive weather warnings for Aisha. Jocelyn wasn't quite as severe, but it just meant that the clear-up operation was much more challenging afterwards. So we had two very contrasting storm seasons. So 22-23 was actually a very quiet storm season, with only 2 storms occurring and very late in the season, so right at the end of August. Whereas we had a real bumper storm season in 23-24, so great for writing a report, with about 12 storms between, I guess, September and August of this year. We also had 2 quite severe storms, so we had Babbitt and Aisha with red weather warnings, and we had 2 separate instances of storms occurring in quick succession, so Elin and Fergus in December and Aisha and Jocelyn in January. So in terms of how we looked at these storms, we looked at the daily maximum 10-meter wind gusts for the UK, and we also looked at the aggregate precipitation as well. And you can see that different storms sort of pop out with different characteristics. Bakut, there were lots of issues with rain. Kieran was more winds, but because it was sort of diverted to the south, we don't actually see sort of the worst of the winds if we just aggregate over the GB landmass. You've got Elin and Fergus occurring in quick succession there, same with Aisha and Jocelyn, really bad winds during Aisha. And then during the sort of Christmas period, we had Pia and Gerrit, Pia having more of a sort of windstorm type impact and Gerrit having more issues with rainfall. And then there's the names of all the storms there. Cool. Another way that we looked at the more regional impacts is by looking at storm and precipitation footprints. So these wind footprints are the maximum 10-meter wind gust within a 72-hour period centered on the storm date. So you can see some of them that I'm going to explore today. So Aisha and Jocelyn, very severe winds. I think because these occurred in such quick succession, the 72-hour window around Jocelyn is just picking up the same winds as it did for Aisha. I'll also go into more detail about Bakut and Kieran, where for Bakut, the impacts were mostly in eastern Scotland, whereas Kieran, they were in the Channel Islands and more sort of northern France. And this is quite similar with the precipitation footprints as well. You can see in sort of on the western coast, Aisha and Jocelyn were very impactful, whereas for Kieran, it was really in the Channel and particularly eastern Scotland for Bakut. So Storm Bakut occurred on the 19th of October 2023. We had the storm moving in from south to north, which is apparently quite unusual. We had these stationary fronts stuck over Scotland, producing lots of heavy rain. So the Met Office put out various sort of weather warnings for this region, including one for a red warning for the county of Angus. I think that was a pretty good warning because I think Angus recorded their heaviest ever day of rainfall since 1891. And you can see this in the sort of precipitation anomaly plots. So we have about 200 millimeters of rain occurring in this region in about 3 days, which is about 200% of the climatology. So yeah, really heavy rain at that time. Again, this is sort of backed up by our storm footprint, where really we see the worst of the impacts in eastern Scotland. And this obviously led to outages. So Northern Power Grid, which operates electricity in the northeast of England, I think there are about 40,000 outages there. There were lots of outages in Scotland. I think that was where most of the issues were. And part of the challenge with this was because there was such heavy rain, it meant that actually accessing sort of customers that were offline was quite challenging. Next, we have Storm Kieran, which occurred in early November 2023. There was a lot of sort of media attention for Kieran because it sort of underwent similar development to the Great Storm of 1987. Fortunately, the impacts occurred sort of further to the south than the Great Storm, and so a lot of the worst impacts were avoided. But the severity of it can be seen in the shipping forecast from Plymouth, suggesting that perhaps hurricane force 12 winds were going to be experienced later, which I think is the worst category on the Beaufort wind scale. You can see the impacts across northern France and the Channel Islands here with wind speeds of over 100 knots. But still, it was pretty bad in the southwest and the south coast of England with wind speeds of over, looks like about 60 knots occurring in some regions. This caused outages in the south of England, I think a total of around 150,000 outages. I think schools closed in Devon and there were around 1,000 outages. And then in Surrey, trains had to stop and I think there were around 7,000 outages. Finally, storms Aisha and Jocelyn, which occurred in late January 2024. Here you can see Aisha just moving across the north of the UK with Jocelyn just waiting in the West Atlantic there. And just a day later, you can see the weather fronts of Jocelyn almost sort of reaching Ireland. For this, well, for Aisha, the Met Office put out quite extensive weather warnings covering much of the UK. I think this was quite unusual because normally orange weather warnings don't cover, or amber weather warnings don't cover that much of the UK. And you can see the severity of the wind impacts from the footprints here. This brought down power lines, with most of the impacts occurring in the northwest and Northern Ireland. And I think over 300,000 customers were left without power, and this was mainly distributed between Northern Ireland and the Republic of Ireland. And because of Jocelyn occurring not long after Aisha, it meant that there were real issues with getting people back online, and a lot of people were out for much longer than they would have been otherwise. So in terms of a summary of the infrastructure section, again, I think it's important to highlight the resilience of the UK power system. We had a very active storm season. We had some quite severe storms, but we didn't have any widespread sort of national scale outages. Despite this, however, as we've explored, we know that there's some regional outages. So Storm Babette really affected Eastern Scotland, Kieran, Southern England, and Aisha affected Northern Ireland. And I think it's important to highlight that the impacts of Kieran could have been a lot worse as well, potentially, if there had been sort of slight shifts in the storm track. The frequency of storms caused issues, particularly when they occurred in quick succession. I didn't go into detail about Lynn and Fergus here, but it was a similar sort of situation to Aisha and Jocelyn. And there's a lot of uncertainty with climate change and severe storms, sort of like I previously mentioned, but some studies do suggest that severe windstorms are likely to become more frequent in the UK with climate change, which will potentially cause further impacts for DNOs in the future. So they have to deal with more of these events in a given winter. So what's next? So I think really the main finding from the report is that the UK power system is resilient, which is quite a nice finding to sort of come up with. But we know at the same time that the climate and the power system are both rapidly changing. We're due to experience between an extra 1 degree to, I think that's about 4 degrees of warming by 2100, depending on the sort of scenario that's picked. But the landscape of the power system is also changing rapidly as well. So it took us between 2008 and to 2023, so 15 years, to get from 3 gigawatts of installed capacity of wind power to 30. I think there's currently ambitions to bring this up to 90 gigawatts by 2030, which is a rapid scale of change. I mean, yeah, whether or not that will occur by 2030, we'll see, but the ambition is there. But this is just one aspect of the energy system as well. So National Grid produced these future energy scenarios where they look at the sort of different dimensions of the future power system and how they might project for it to change. So do we move towards hydrogen or do we electrify? How much demand flexibility is operated? And how much do we sort of continue to include natural gas in the mix? So both things are changing, the climate and the power system. But I think what the difference between the two storm seasons sort of demonstrates is that each year brings very different challenges. We had one storm season that was kind of quite quiet and relatively inactive, and we had another that was incredibly busy with 12 storms, some of which being quite severe. So I think internal variability is definitely plays an important role in this as well. And yeah, I guess one of the main sort of points from this report is that if we want to better anticipate and better sort of understand impacts of the future climate on the future power system, we want to understand the present first and the impacts that has. So yeah, I guess that's the State of the Climate for the UK Energy Sector report, which we've been working on over the summer. We're hoping to release that in the next 2 weeks or so. So I think that's a week on Thursday, along with an executive summary document. We have a sort of sign up link to the mailing list here if you want to hear about any future events. Our next future event, which we've got happening, which I'm really looking forward to, is the seasonal forecast outlook for the energy sector. So here we've got Hazel Thornton from the Met Office delivering the winter forecast, followed by Antje Weisheimer from ECNWF, sort of responding to that forecast, identifying common forecast signals. And then we've also got Jan Dutton from the World Climate Service and Lucy Field from AFRI to talk about the implications for the electricity and gas networks. So sign up to the event here and the mailing list there. I think I'll leave that slide up at the end. Thank you all for listening. Do you have any questions?